Okay, this is a criticism of minute physics. In a previous video I came across a person talking about physics who was criticised by minute physics, so I thought I'd have a look at minute physics. So I'm looking at minute physics video on Einstein and the special theory of relativity. It's on that website, web address, and the idea of these minute physics videos is to give a quick look at certain parts of physics. It wants to deal with special relativity in 2 minutes. The problem with that is to try to cover the subject in such a short time is to totally distort it. If this is typical of modern education in the 21st century, that it does not expect students to be able to give more than a few minutes attention to the subject, then no wonder they are stupid. This whole thing by minute physics is just a dumbing down process. To deal with the subject adequately requires more than a few minutes, and that if you dealt with the subject longer, then I would point out far more which is nonsense in Einstein's relativity. So, conclusion, despite its cuteness and trying to get directly to the point in a few minutes, it is totally valueless. So now we look at the video. Here we go. Make it bigger. And I need the sound. Got the sound.
In 1900, all of physics, and particularly Einstein, was in trouble. They couldn't figure out how anything could move. Now, before you complain that I'm exaggerating, check out this cat. You can clearly see that the cat is moving away from Einstein at a constant velocity. But do a little sliding switcheroo, and suddenly it looks like Einstein's the one moving. This is the old-fashioned principle of relativity. But the point is that the switcheroo changes relative things, like position and velocity, and not absolute ones, like the separation of Einstein from his cat. Now for the problem. Before Einstein was even born, physicists showed that the speed of light was one of those absolute things which can't be changed by a switcheroo. So any switcheroo we do has to keep light moving at the same speed. But then it's obvious that we can't do our sliding switcheroo at all, which means we can't explain how anything other than light can move. Okay, I spoke too soon. There is one solution. Do you see it? We were assuming that our switcheroo had to keep every slice of time at the same, well, time. But there's no law of physics that says time is an absolute thing that can't be changed by switcheroos. So if we just rotate the slices of time while sliding them, then we can keep the speed of light the same, and explain how things can move too. Of course, Einstein didn't figure out this special principle of relativity in 1905. It was already done by a guy named Lorentz 10 years earlier. But Lorentz just thought that this time rotation was a mathematical trick, and it took Einstein to step in and, you guessed it, propose that time rotation is real, that time really is relative, and that consequently, simultaneous events relative to one observer aren't simultaneous relative to another. Now that's a real switcheroo of perspective.
Right, so that was the video, and how can they think that it's got any value attached to it? It's completely worthless. It's whiz whiz whiz, nothing there, nothing of any substance whatsoever. It's what whiz what? What's all that about? So let's criticise it now. How can they think that's? How can they think something like that is worth anything? Right.
In 1900, all of physics, and particularly Einstein, was in trouble. They couldn't figure out how anything could move.
What? What are they talking about? They couldn't figure out how anything could move. Not even Einstein. What's it? What?
Trouble. They couldn't figure out how anything could move. Now, before you complain...
They did say Einstein, didn't they?
Was in trouble. They couldn't figure out how anything could move. Now, before you complain that I'm exaggerating, check out this cat. All of physics.
Let's go back.
1900. All of physics, and particularly Einstein, was in trouble.
Yeah, particularly Einstein was in trouble. Oh, dross. Particularly Einstein was in trouble. They couldn't figure out how anything moved.
They couldn't figure out how anything could move.
What a load. Is that a way to start with this? We're going to get into special relativity, and particularly Einstein, they couldn't work out how anything moved.
Now, before you complain that I'm exaggerating...
Now, before you complain that he's exaggerating. So he's admitting to some extent he's talking rubbish. Just in the first few seconds. Before you admit I'm exaggerating. It's just complete distortion. So pathetic.
I'm exaggerating. Check out this cat. You can clearly see that the cat is moving away from Einstein.
What? They're just static pictures. Just static pictures. This person with funny hair, that's supposed to be Einstein. And he's got a cat here, and the distance of cat and them apart is there at a moment in time. 1 second later they're supposed to be this distance apart, and then 2 seconds they're supposed to be this distance apart. So it's representing movement. And they don't. And he's supposed to have a problem of understanding how things move. Bloomin' heck.
Cat is moving away from Einstein at a constant velocity. But do a little sliding switcheroo, and suddenly it looks like Einstein's the one moving.
That is a pathetic way of showing the idea that relative to that reference frames move. This is such a bad way of showing it. It's just so bad. If you could imagine this person and this object move, well, this creature moving away in empty space, then relative to his frame of reference the cat is moving away, but relative to this cat creature's frame of reference this person's moving away. And that's what they're trying to talk about. But putting it like that, this person should be looking around in his surroundings and seeing things like trees and so forth, and you look at the cat and the cat should ideally be walking away. Then that person knows that I'm stationary and the cat is moving, but the cat should know that it's moving. So this is complete farce.
It's like Einstein's the one moving. This is the old-fashioned.
Well, that's the old-fashioned relativity. That's Galileo relativity. So, ye old relativity. Einstein, with his supposed say problem with not understanding how things move, ideally should start off from understanding physics' Galileo relativity, and ideally all the physicists of his day should have understood that, should have understood Galileo relativity. So it's motion which is relative between observers. And next Einstein's going to mess up relativity and have time varying and other messed up things like that.
Like Einstein's the one moving. This is the old-fashioned principle of relativity. But the point is that the switcheroo changes relative things like position and velocity.
Changes relative things like position and velocity. So both Einstein and the cat should be agreeing about the time. So that's 1 second passed, and then it's 2 seconds passed, and ideally they should be agreeing about time. We've got to try to imagine the cat as being bothered about using watches and clocks and things. So this person with a clock, and ideally you should have another person with a clock here, and they're both agreeing about time passing. Both clocks should be operating at the same rate, and so they're both saying 1 second's passed, 2 seconds passed, and they're both agreeing, and that's Galileo relativity.
And velocity, and not absolute ones like the separation of Einstein from his cat. Now for the problem.
So now for the problem. And they take the problem all the way back to Einstein being born. Yeah. Einstein created the problem when he was born.
Before Einstein was even born, physicists showed that the speed of light was one of those absolute things.
No, that is a lie. They didn't do that. They didn't. That is a lie. If I can find it. There you go. In my video, it's the lie upon which Einstein's relativity is built. So straight away they're telling you a lie. It's a lie.
Things which can't be changed by a switcheroo. So any switcheroo we do has to keep light moving at the same speed. But then it's obvious that we can't do our sliding switch.
Yeah. So now we have to build upon the lie. So basically this is the next step. If you are believing the lie, then you've got to build on it, and you've got to do some funny stuff. So I'll try to get it back a bit. Seem to have lost my place now.
At the same speed, which can't be changed by a switcheroo. So any switcheroo we do has to keep light moving at the same speed. But then it's...
So in this diagram, you've got this matchstick man. It's supposed to be Einstein with a torch or a light of some sort, light bulb, and light's leaving it, and the light is supposed to get there after 1 second, and there after 2 seconds, there and there, and suddenly he's got this light source here, and suddenly the light source disappears. So presumably it's supposed to be something like he's turned the light source on here now at this moment, and it must be further down here because the light has got to here and here at now. So presumably he must have turned it on here, and then at this moment in time it's got to here and here, the light from either direction. So this diagram is not very good. But that's the basic idea.
But then it's obvious that we can't do our sliding switcheroo at all.
Obvious, is it? Obvious now, is it? Where you could do sort of like mess around a bit with the mass and so forth. So you're saying it's obvious, but well, we could mess around with mass, couldn't you? Try to do something funny, like try to appeal to a higher dimension or something weird. So what does it mean, obvious?
Switcheroo at all, which means we can't explain how anything other than light can move.
Can't explain how anything else can move other than light. What are they talking about here? They're sort of bluff. It's all bluff. Even given the idea that the speed of light's constant, and they're suddenly saying you can't work out how other things move. What are they talking about?
Can move. Okay, I spoke too soon. There is one solution. Do you see it?
There is one solution. So suddenly there is a solution. Light could be constant, and suddenly there is a solution to how things can move. So. Despairing this is.
Do you see it? we were assuming that our switcheroo had to keep every slice of time at the same, well, time. But there's no law of physics that says time is an absolute thing that can't...
So, what we're doing, we're going to play around and say that time is not special anymore. So, I'm going to play around with that idea as opposed to playing around with any other idea. So, why? Is the immediate question. Why are we going to play around with that idea as opposed to other things? And of course, they don't have got time to go into that, so it's quick, rush on to the next thing. Next thing, just create more and more confusion. Time is not going to be special for some unknown reason.
Thing that can't be changed by switcheroos. So if we just rotate the slices of time while sliding them, then we can keep the speed of light the same and explain how things can move too.
So, this is supposed to be distance, I suppose. It's still these distances apart. That's sort of, it doesn't look quite, is that, I suppose it's supposed to be the same distance between there and there. Okay.
Of course, Einstein didn't figure out this special principle of relativity in 19...
So, Einstein didn't do that. Einstein didn't think out this special principle of relativity. I think that's completely wrong. It's Einstein who's coming up with the idea of the principle of special relativity. I don't think it's other people doing that. It's they're trying to say somebody else did it before him now. And you're going to talk about Lorentz, and I don't think Lorentz was talking about the special principle of relativity. I think Lorentz was talking about Galileo's relativity. So they're getting all this muddled. It's sort of, you've got 2 minutes to talk and you're just going to blunder away about what you're talking about, leaving lots of confusion on the way. You're going to change time, but why change time as opposed to trying something else? This is all just complete distortion.
Special principle of relativity in 1905. It was already done by a guy named Lorentz 10 years...
Yeah, Lorentz. Lorentz was actually working from the experiments of things like the Michelson-Morley experiment, and he was working out the maths for it and so forth. So, to get back to again, I'm not happy when they said this about this Einstein. All worked out before Einstein.
Of course, Einstein didn't figure out this special principle of relativity in 1905. It was already done by a guy named Lorentz 10 years earlier. But Lorentz just thought that this time rotation...
Yeah. So, they're muddling up Lorentz and Einstein, just getting it all confused.
...was a mathematical trick. And it took Einstein to step...
Yeah, the mathematical trick thinks Lorentz, and that's wrong. I think Lorentz was thinking of it more than a mathematical trick. So they're not even being accurate on it.
Einstein to step in and, you guessed it, propose that time rotation is real.
So blooming heck, they haven't got Lorentz right. If we go to Lorentz, this is on Wikipedia. This is what Wikipedia has to say about Lorentz theory. What is often called Lorentz ether theory has its roots in Lorentz's theory of electrons, which was the final point in the development of the classical ether theories at the end of the 19th and the beginning of the 20th century. So at the end of the 19th century, Lorentz was working on this idea, and this was before Einstein. Lorentz's initial theory, created in 1892 and 1895, so he must have developed it further in 1895, was based on a completely motionless ether. It explained the failure of the negative ether drift experiments to first order in VOC by introducing an auxiliary variable called local time for connecting systems at rest and in motion in the ether. So what we're talking about in Lorentz time is ether. And there's a lot more here which I'm not really happy with what Wikipedia says, but you get the general idea. Lorentz had a theory and it's something to do with ether. And he's talking about local time and so forth. And so suddenly you've got all that from the person Lorentz. We go back to him. Here. Or not here. Here, Lorentz. You got Lorentz with a theory in 1895, and then so you got Einstein with a theory in 1905, and you're sort of like crediting Lorentz for a lot of things. And so you've got this transition from Lorentz's theory to Einstein's theory, and sort of like how do you do that? They're just glossing over it. They're not going into the details. If they went into the details, I would start complaining about that, because they probably got it wrong. Well, probably. But now they're just trying to gloss over, here's Einstein, and he's going to change Lorentz's theory.
But Lorentz just thought that this time rotation was a mathematical trick.
Mathematical trick. I think that is complete and utter distortion. Mathematical trick. It's a mathematical trick, plus he was talking about something called local time and ether.
And it took Einstein to step in and, you guessed it, propose that time rotation is real.
What? If it's a mathematical trick, how do you suddenly make the leap of saying it's real or something? What are they talking about? They've missed out too much.
Time really is relative.
Time really is relative. How do you get that? How do you suddenly get that? Mathematical trick, and it's suddenly time is relative. So how does that done? They've sort of jumped over that.
And that consequently, simultaneous events relative to one observer aren't simultaneous relative to another. Now that's a real switcheroo of perspective.
Real switcheroo. Completely glossed over everything. Nothing of real value in there at all. It's sort of ye olde relativity, Galileo's relativity. How do you get from Galileo's relativity to suddenly Einstein's relativity? You've got some theory by Lorentz. How do you get from Lorentz to Einstein's theory? How does it suddenly become Lorentz's theory about local time and ether to Einstein's theory? They completely missed out all that. This is completely worthless. It doesn't tell you of anything of value. They think that is worth something. Oh. We can look down now for some of the comments. If I maybe make this larger. Here we go. Here we go. Traveling food. Traveling time would bring us living. Traveling time would bring us living into, 75 dimensions. What? I don't understand that. Actually, that's what it says. Actually, no matter what direction you go, time only slows down a bit relative to your speed. I don't know. In a previous video, pointing out that saying moving clocks run slow is a bad way of talking about Einstein's relativity. It can completely distort the picture, so sounding like this person's doing the same. Right, somebody's saying here, designating the speed of light as a constant and time as a variable is an assumption. And somebody replies, it is not an assumption. So they're getting confused over whether it's an assumption or not. And according to this person, it's a definition, not an assumption. So speed of light, constant, according to this person, it's a definition and not an assumption. The previous person is saying it's an assumption. So what is it supposed to be? Is it constant, or is it by definition, or is it assumption? Anyway, going by this person, the special theory of relativity defines C as constant and T as observer dependent, and this theory and the mass that comes out of it can be used to explain certain real world phenomena such as time dilation. Special relativity is not a description of the universe. We might find some weird scenario in the future where C changes value, but as far as special relativity goes, C is constant. What does that mean? What's that supposed to mean? It's a definition. So if speed of light is a constant by definition, it can't change. Suddenly he's thinking it might change in the future. What? So is a constant defined within special relativity? So if this doesn't help, think of the Pythagorean theorem. We define the triangle as a right angled triangle. It might not be, in which case we can't use the theorem. These people talking about relativity, and they're totally utterly confused about what they're talking about. Is there any other comment? That was the end of the series of comments on that one. And so somebody else says, well, some of it's just bad language. So we get back to my video here. In my video I explain that it's two different theories. If you assume the speed of light to be constant, you can then test that idea by experiment. And what they actually found was they were not able to prove by experiment that the speed of light in vacuum, free of fields, in inertial frames and so forth was a constant, so they defined it as constant. So this is where some of the confusion is going. So that person who's saying, we go back, this person is thinking speed of light constant is an assumption, and this other person saying no, it's not an assumption, it's a definition. So that is part of where the confusion is coming from. One person is saying it's one thing and the other person is saying it's something else, but this person, after recognising it's a definition to give the speed of light as a constant, then seems to get completely utterly confused, because he's then thinking maybe the speed of light can change. You can't find the speed of light changing if you defined it as constant. It's not then possible. The knock-on effect of defining the speed of light as constant is to have time as variable. So where we go back to this. So this video, Einstein and the special theory of relativity didn't go into anything about that, or whether it's a definition or assumption or whatever. It just gave you that little bit, which is a lie, about how they had a problem that they measured the speed of light as constant. And that's just a lie. They didn't. So this is complete. It was just didn't have enough time to deal with the subject properly, and so it's giving you something which is no use to you. It's just no use. Conclusion, back again. So conclusion, despite its cuteness and trying directly to get to the point in a few minutes, is totally valueless, is worthless, doesn't deal with the subject properly at all. Thank you.